Hey, what's happening, guys? Today we're going to do a little bit of soldering because it's nice and relaxing. That's what I need. So this is analog electronic candle lights and blowing control simulation candle. This kit was sent to me by good buddy Uncle Rob, purveyor of Uncle Rob's Magic Solder Flux. So, what do we have? We have instructions in Chinese. Alright, maybe we can figure it out ourselves. We should be able to do that, right? We are smart-ish type people. So let's start off with this IC here, which is a CD4013. Well, the CD tells us it's a CMOS chip. The 4013 is its identifier. In this case, it is a dual flip-flop, I believe. So, if we follow our power comes through here, can flow to this transistor, turning up that capacitor, potentiometer, pins. All right, so we have the microphone here. When the microphone is activated, I'm guessing by blowing on it, but I'm sure any sound that will activate it will work. It's going to act like close the switch, which is going to energize those two transistors, and it's going to send a signal to pin 4. And somehow it's going to turn the things on and off, right? Well, let's see what we got here. So here's our circuit board, and thankfully it is labeled so we can find all of the pieces that we need. Two resistors there. 3 resistors there. And 2 singles. There's our CD4013 and a chip socket. We have some ceramic capacitors, some transistors, potentiometer, microphone, an LED, and an infrared LED. So I see D1 here. HW RX. Could that be some sort of receiver? Is it a infrared receiver? Okay, so I use Google Translate, and this one up here, that corresponds to this black component, which is some sort of an infrared receiver. If you use a cigarette lighter, that will activate the circuit, as well as the microphone down here will activate the circuit. So we're going to get started with the smallest components first, which are, in our case, the resistors closest. I'll be using this little 2.5-inch 3D printed vise to hold things, and yeah, it's nice, slides around on the desk, kind of like a cross between a little machinist vise and a drill press vise. I say it's more like a drill press vise because it has slots, whereas a machinist vise would have fixed mounting points. All right, enough rambling. Let's get set up for the soldering. I didn't make you watch me put in the first 4. I figured I'd cut you a little bit of a break. I mean, all I'm doing is bending the leads and putting them in their correct places. This is my relaxation. One of them anyway. Okay. All the resistors are in. They're in their places. And to solder this, I'm just going to flip it over. Make sure everything is held down securely. All right, let's get started. Solder these resistors in here. A little bit of solder on there for thermal transfer. There we go. Rotate that around a little bit so I can see better, and perhaps you can see better as well. Remember, you want to cover the entire joint when soldering. That pad, that shiny little silver pad, make sure it's all nice and covered up with solder. And make sure the solder comes to a point like a little mountain or a Hershey's Kiss. You know, something along those lines. That is the shape we're looking for here. And it should be nice and shiny. Not dull looking. Those are just all marks of a good solder joint. I know I'm kind of hopping around and soldering these here. The thing with soldering on YouTube is I'm looking through a camera, so I have no depth perception. And I'm trying to keep the PC board in frame so that you can see what I'm doing. And you know, it can be tricky. So if I don't look as steady as you would expect, because I'm moving my head around in weird ways to try and see. Sometimes it works, sometimes it doesn't. All right, did I get them all? Yeah, screwed that up though, didn't I? Wah. I'll fix it. That's why you should really only do one at a time, right? All right, now we're moving on to the capacitors. First one, C1, is a 103. Just like that. Then I'm just going to bend the legs out so they don't fall out. C3 is a 104. We'll get that in there. C4 is a 102. There's a 102. And our last one is another 104. There it is. Now we'll get those soldered in. Okay. Let's solder these capacitors in here. See, by splaying those legs out, they'll hang there in that nice little space underneath. And it won't fall out, and it makes it easier to solder. You could do that with resistors too. I think there were just too many of them. Too much of a mess. It's like a forest of resistor legs rising up in the air. Yep. Those are all done. Get them all nice and trimmed. And we'll move on to what's next. Probably do the transistors next. So we've got two 9012s and two 9013s. Let me get them sorted out. Okay, so you can see they're actually two different sizes. The smaller ones are the 9012s. So they go in this direction. And I'm just going to pull those legs a little bit. See if I can get them to fit in the holes. Yeah, that went in easy. One more. This is a nice board to work on. It's single-sided. So, you know, you don't have to worry too much about if you make a mistake and you need to unsolder something. You know, with a double-sided board, that can be a wee bit tricky. Okay, so I think we'll do these two 9012s first. All right, let's get these last ones soldered in here. And then we'll be down to the LED, the microphone, the pot, and the IR receiver. I'm interested to see this kit actually working. To see what it's going to do to that LED. It's going to make it flicker somehow, but you know, they say electronic candlelight, so it'll be interesting to see how they're going to make it flicker using digital devices, which are simply on and off. But we'll find out, right? All right. Might as well go ahead and put our socket in next. Just trying to make sure all the legs are reasonably in order. Take your time with these, you know, just kind of feel them out as best you can. And if you need to adjust things as you're going, you can always get a little something small like that and just kind of smooth the pins in, you know. Just want to smooth them in. Don't want to use any real force. Then when doing these sockets, what I like to do are opposite corners. Because once you've got your opposite corners, yeah, you're pretty much locked in. It's not going anywhere. Now you can just go on down the line. Get all these soldered up, and we should be just a minute or two away from plugging this in and seeing how it works. Looks like I got a little bridge there. Just come at it with a clean iron. The solder will be attracted to the iron and you can clean it right up. No worries. Okay. Do the microphone next. You see there's a little plus mark there. Is there a mark on the microphone? Alright, audio is not my gig, but I believe the side that has the traces heading for the case and the dot to be the negative side, I believe. Oh, and it's going to fit perfectly on there, so very nice. They did a nice job with that, so we didn't have to wonder too much about what was what. I appreciate that. Get that mic soldered in here. Trim it up. And we'll do the potentiometer next. It's a 100K pot. Yeah, summer's almost over, guys. It'll be September in a couple days. The only good thing that comes from the end of summer is football. Other than that, I wish it'd just stay summer. Because here in Ohio, the 4 seasons are almost winter, winter, still winter, and road construction. So right now we're in road construction, which is annoying, but I'd much rather have road construction than snow and ice and all that crap. Alright, which one is the diode? D1 is the LED. Long leg positive, anode. Triangle points to the cathode. So that goes in like so. We'll get him in there, we'll solder it up. The joy of soldering. How many? I know it has to be relaxing for some of you like it is for me. Let me know down below if it's something you consider particularly relaxing. That solder joint looks like not a good solder joint. That's what it looks like. So we're gonna reflow that, make it look prettier. Okay. So now we are down to our IR receiver. Same way. Pardon me. All right. Let's solder up this last one, and then all we have to do is put the IC in the socket. Put some power to it. I want to thank you guys who like to hang out and watch me solder. I appreciate it. All right, now for the IC. All right, I've got all the lights out. I got 3 AA's here, which will give us 4.5 volts. Turn it on. I saw a little flicker there. Here's our lighter. Let's light the candle. The candle is lit. And now I can blow it out. Oh, didn't stay lit for very long. Hang on. Here, I'll do it again. It is cute. Candle's lit. Candle's out. That was fun. Hang on, I'm gonna turn the lights on. And I really needed that. So now that I see it, I understand. Okay, this LED is not a regular LED. It has a chip in it that makes it do the RGB LED thing. Does it say RGB LED on here? It just says LED. I might say RGB. I don't know. I don't read Chinese, you know? So it's waiting for this to be activated. So when this thing activates, it's sending a signal there on pin 6. And then it waits for another signal to come in on pin 4 to deactivate it. So it's just setting and resetting the flip-flop. Cool. Very neat. Let's see, is it working the light too? Yeah. There we go. All right. I want to thank Uncle Rob for sending this out. I want to thank you guys for watching. That's it. I'm out.